Alright guys, welcome back. Hopefully you guys attempted to do these problems on your own and you're not just copying what I have down, because that's not the point of this. So let me go over these questions fairly quickly to give you guys the answers and to give you a brief explanation of each. The first one gives us a rectangle and it wants us to find the area. It's pretty straightforward because area, as we know, is just length times width. And even though we have expressions instead of numbers, you still go about it the same way. We're still going to take our length, which we can call 5x squared, and then we want to multiply that by our width, which is 2x cubed cubed. Before we even do this though, I'm going to simplify that down. So I'm going to take 2x cubed cubed and actually apply the power to a power rule. So remember, it goes to every exponent on the inside, so that's 2 cubed x to the 9th, and we know 2 cubed is just 8. So this is actually 8x to the 9th. Because again, remember, power to a power, 3 times 3, 3 times 1, that's that. From here, I'm going to line everything up. Again, you do not have to do this. I'm just doing it to show you why this works. 5 times 8 is 40. X squared times x to the 9th. Remember, this is product of powers now, product of powers. So when you multiply like bases, you have to add the exponents. 2 plus 9 is 11. 40x to the 11th. Again, we don't know what x is, so we can't actually figure out what the area is per se, but it's still 40x to the 11th. Next, fill in the blank. So if I'm looking at these problems, guys, I can tell that there is a blank exponent outside of each set of parentheses. That means we're using the power to a power rule. So this says b squared to some number equals b to the 8th. So again, when I use some exponent, when I raise this to some power, I need to get b to the 8th. If we remember our power to a power rule, it states that you multiply the exponents together. So basically 2 times what is 8? That's easy enough. That's 4. Next one. 9n to n to the 9th times some power equals n with no exponent. We know with no exponent, that's just n to the 1st. So instead of getting larger, this exponent decreases. So I need to multiply 9 by something to get 1. So if you guys thought about it a little bit, you know that we just need the reciprocal, the multiplicative inverse. Because again, 9 times 1/9 is 1. So n to the 9th times 1/9 is n to the 1st. And finally, we have y to the negative 4th to some power equals y to the 1/2. First and foremost, I hope you guys realize that we went from a negative exponent to a positive. That means whatever answer we have has to be negative. Because again, we need a positive exponent in the end. So then you have to ask yourself, what do I multiply 4 by to get 1/2? Again, what do I multiply 4 by to get 1/2? Well, that's just 1/8. Because again, 4 over 1 times 1 over 8 is 4/8, which is 1/2. So again, guys, you can see how fractions are starting to play a role, and these rational exponents, these fraction exponents, are also, there's something else going on, but that's for another lesson next week or down the road. So you'll see what fraction exponents actually mean, but for now, don't worry about it. Just use them as we would use the rules. Number 3. It says, reasoning in a sentence or two, justify whether x squared cubed is the same as x squared to the 3rd power. Remember, this right here tells me I have 3 of these things. This tells me I have x squared times x squared times x squared. This right here does not tell me that. This just tells me x squared raised to the 3rd power. The x squared isn't raised to the 3rd power, just the 2. Just the square is raised to the third power. So again, guys, understanding these subtle differences in these problems and understanding what's raised to which power is going to be truly important when solving these problems. This we know is x to the 6th. This right here, if I actually do 2 cubed, that's 8. That's x to the 8th. These are not the same. These are not the same. So again, the whole point behind this problem was not, it was to make sure you understand the difference between a set of parentheses and not a set of parentheses. Again, this cubed is telling me I have 3 factors of x squared. This right here is just telling me to cube the 2. So, make sure you understand that. Again, in a sentence or two, I know I didn't write a sentence, but if you guys wrote anything along the lines of the 3 factors of x squared versus 2 cubed, and that's really x to the 8th, as long as you wrote some sentence saying that, you guys are in a good spot. And again, this is to get you write more and to justify your math, because writing is going to be huge coming down the road, and you guys need to be able to communicate your mathematics correctly. Number 4, are you able to write 49x squared y squared z squared using only one exponent? Show how or explain why not. So basically, right now we have 1 exponent, 2 exponents, 3 exponents. We need to only use 1 exponent. So if you guys thought about this at all, you obviously have to have a power to a power. If we bring the 2 on the outside, it's like reverse distribution. It's kind of like factoring to an extent. And x, y, z, if I bring this 2 inside to all of them, I have x squared, y squared, z squared. But remember, we have to have the exponent go to everything. So I cannot put 49 here. If I put 49 here, 49 squared is definitely not 49, so I'm completely wrong. But if you're thinking backwards, and if you're undoing this, you know that 7 squared is 49. So basically, I kind of took the square root of everything and brought the square on the outside. That is a little bit more complicated and a challenging of a problem. It makes you think a little bit more, and it really digs deep in the conceptual understanding of what these laws of exponents mean. Again, I'm trying to push you guys in further and beyond, because exponent laws are crazy simple, so I'm trying to get you guys more of these problems to really push the envelope. So that's it for these practice problems. As you can see, all my explanations are here and or my work. Below, you'll find the exit ticket. Again, guys, try your best on this. Take your time. Do not make silly errors. Again, I want to see how much you guys know from this lesson, and hopefully we'll be good to go. So again, good luck. Best of luck on the exit ticket. Make sure you hit that subscribe button, because I want to be popular on YouTube, because that's the cool thing to do. And I'll see you guys later.